Hello. So for this video, we're going to be solving quadratic equations, right? So this is starting chapter 11, section 11.1. And just to remind you, you should know what a quadratic equation is because we have seen them earlier. But a quadratic equation written in its standard form looks like this. So you have ax squared plus bx plus c equals 0. Right? So that's the standard form. And a, b, and c are just numbers, right? Usually they're nice whole numbers, integers, but they could be fractions. They could even be decimals. When you see them, you'll see them mostly as integers and occasionally fractions as well. So a cannot be 0 because, if a were 0, you would have an equation that could look like this, right? You might just have, 3x minus 6 equals 0, and that would be a linear equation, which you know how to solve, right? So without the x squared term, right, then it's not considered quadratic, it's considered linear, right? So b or c could be 0. I'll leave this up, right? B or c could be 0, but not a. So let's review something we did way back in chapter 6, I believe. Yep, when we were factoring. You can solve quadratic equation, right, by factoring. In some cases, right? So here's a good example of that, one that you may have seen before. Suppose you want to solve the equation. Let's just do x squared equals 3x plus 40. So how could we solve that? Well, first note that this is not in standard form. Not in standard form because it doesn't equal 0, right? You have to have 0 on the right side. So to put it in standard form, let's just take away the 3x from both sides. So x squared minus 3x equals 40. And then to get rid of the 40, we would subtract 40 from both sides, right? Just do the opposite, right? So that gives you 0 on the right. And it gives you x squared minus 3x minus 40 on the left, right? So this is now standard form, right? So this is standard form. And we can recognize it because, right, a is 1, b is negative 3, and c is negative 40. So something you've done before, as a reminder, can we factor the left side? Can we factor x squared minus 3x minus 40? Right. Well, this is just, you can use the AC method, but since a is 1, we can even use the shortcut method. What two numbers multiply to negative 40 and add to negative 3? So let's write them out if it's not obvious, right? So we have negative 40, right? We can do 1 times negative 40, right? Or negative 1 times positive 40. But when you add those, right, when you get the sum, you get positive 39, which is not right. We're looking for b, right? We're looking for negative 3 here. So it doesn't add to negative 3, and it doesn't add to a negative. So if you do the bigger number being negative, 1 minus 40 would be negative 39, right? Which is still wrong, but it's negative, right? So you can also do, right, 2 times negative 20, and 2 minus 20 is negative 18, still no match. I don't think it's divisible by 3, so if we divide by 4, we get negative 10, and 4 minus 10 is negative 6. Still no match, but we're getting closer. If you divide by 5, you get negative 8, and 5 minus 8 is negative 3. There's our match. So the two numbers, right, that multiply to negative 40 and add to negative 3 are positive 5 and negative 8. So again, it's a good review of factoring. But remember, we're not done because the question wasn't to factor. The question was to solve this equation. So remember, we have one more step. Now we have to solve, in factored form, x plus 5 times x minus 8 equals 0. So yeah, remember how this works. You just set each factor to 0. So x plus 5 equals 0, or x minus 8 equals 0. And when you take away the 5 from both sides, you get x equals negative 5. And when you add 8 to both sides, you get x equals 8. And if you remember, very typical of a quadratic equation is the fact that you get two solutions. Typically, you will get, right, two solutions here. You should check them both. You should check them both back in the original equation, this one up here. Yeah, well, I'll leave that to you. So pause the video, plug them in to this equation up here, see if they work. Yeah, so I'm pretty sure they do. Yeah, so you get two solutions. Although you don't have to, right? Occasionally you get just one solution. But more often you get two. Okay, so that's right, solving quadratic equations by factoring. And this was in section, I believe it was 6.7 in chapter 6. Yes, 6.7. I just had to double check that. So yeah, so I hope this helps. Review factoring. So that's one method that could work, of course. Here's another method. So we'll call this method 2. This is, well, it's the square root method, right? We call this the square root method. And, well, it's, as the name implies, you're going to be taking square roots, right? So let's just start with an example. Suppose you want to solve the equation. So x squared plus 25 equals 0. Right? Well, can we solve it by factoring? So, right, so can we factor x squared plus 25, right? So this is a binomial. And if you're thinking, right, 5, after all, this is 25 is just 5 times 5, 5 squared. Yeah, this is in the form, right, a squared plus b squared. This is prime. Right, this is irreducible, at least for our purposes. We're not, right, we already said that we cannot factor it, right? So you might have been thinking of a squared minus b squared, which indeed does factor as a minus b times a plus b. But because it's a plus sign and not a minus sign, yeah, it's prime. It's not factorable, right? So yeah, as I said earlier, this method of factoring doesn't always work, right? Up until now, it has always worked because we weren't trying to trick you, right? We're not giving you trick questions that you solve this equation, for example, here, if it was not factorable, right? In other words, if this form here was not factorable, you would simply give up and say, yeah, then I don't know how to do it, right? So yeah, so if we can't factor, then up until now, that was the end of the story. But now we have another method, right? The square root method will be able to solve this equation. Right, and maybe just to give you the idea, before we do that one, let's do the one that we do know how to do. Suppose you wanted to solve x squared minus 25 equals 0. Well, you could do it by factoring, right? This is a squared minus b squared, which is a minus b. B in this case is 5, right? Times a plus b. Right? So in this case, it's a is x, right? So a is x, and b is 5. So this factors perfectly here. And as usual, you set them equal to 0. And you get your two solutions. You get 5 or negative 5, right? Two solutions. Okay, so again, this was done by factoring, right? But for example 2, right, for this one up here, right, this is not solvable by factoring, right? So this, right, cannot be solved by factoring. So well, at least not the way we factor. So yeah, so basically don't worry about it, right? All right, so let's look at a different way to solve this equation, x squared minus 25 equals 0. And to some of you, it may have occurred to you that you can also solve this by just adding the 25 to both sides, right? So it's no longer in standard form at this point. However, you may have noticed that I can undo the x squared, right? What undoes the x squared? The inverse of squaring something is taking the square root. So you would simply take the square root of both sides, and undoing the square root, that leaves you with x, right? And on the right side, this is the square root of 25 is 5. And so, sure, that's a correct answer, right? That was one of them, x equals 5. But notice there's something wrong here because we got two solutions here. We also got negative 5 when we solved it by factoring. So think about that. Where's the negative 5? So the answer is it's here. It's just that we didn't write it down, right? Anytime you take the square root of both sides, there's two solutions. One of them is positive and the other is negative. Okay? So we have positive 5, we also have negative 5. Right? So let me say that this symbol here, right, we're going to read this as plus or minus. Right? It can be a plus or it can be a minus sign. Okay. So this is just a shorthand, convenient way, right? So it's no longer a question. This is correct. So we get x equals positive 5 or negative 5. It's just a short way to write both. So when you see this, of course, you should write them separately. You should write it as x equals 5, right, comma, or x equals negative 5. But I'm not picky. If you want to write it this more succinct way, this shorter way, as long as you have the plus or minus symbol, then you're including both. You're doing the positive 5 and the negative 5 together. Okay, so yeah, so don't forget the plus or minus symbol anytime you take, right, when you take the square root of both sides. Okay, very important, because if you forget the negative, if you just did the positive 5 like we did, then you're going to get, well, you're going to get half credit because you missed half the answers, right? You missed the negative 5. So that's right, and you can check that is also a solution, right? So we want both the positive 5 and negative 5 here, right? Okay. Yep. So this is the square root method. Right. And so yeah, the way it works is this. I'll scroll down a little bit. So for the square root method, once again, here's the idea, right? You have something on the left, let's call it u, and it's something squared. And on the right side, you just have some number, I'll call it n. Right? So this u, of course, could just be an x, right? It could just be x squared in most cases. But it could be any form or any any function of x, right? Typically a linear function, but it could involve x, right? It could be x minus 2, for example, right? Okay, so we have something squared equals n. So what is that something? What is u? Well, it's going to be plus or minus, right, the square root of n. Right, and that's it, right? That's the square root method, right? You're undoing the square by taking the square root of both sides, right? And so the square root of u squared, well, we're assuming u is positive, right? Ordinarily, we would get absolute value. And I've said many times, in most cases, don't worry about that. We're just going to call it u, right? And it's going to be either positive square root of n or negative square root of n. And like I said, it's a good idea to write them separately. So I'll write it as the square root of n on the one hand, or u is going to be negative square root of n. Right? Okay, so that's the square root method. Right? So it's pretty simple. However, for this to work, right, remember when you have a quadratic equation in standard form, notice that in both of these examples here, there's no x term. We don't have x squared plus 6x minus 25, right? We don't have bx. In other words, b is 0 here. Right, so for the square root method to work, it's very important that you have b being 0, at least in standard form, right? Now, if you were to expand this out, the u out, then b might not be 0, but let's not worry about that at the moment, right? Right. So the square root method, again, doesn't always work. It doesn't work if b is not 0, right? b has to be 0 to apply the square root method directly. Makes sense? So now we can go back up here and solve this equation. X squared plus 25 equals 0. Right? So here x is my u, right? Remember this is u squared equals n. And here the n is not 25, right? We have to subtract 25 from both sides. So n is negative 25. Right? Yep, so getting it out of its standard form, we just subtract the 25 from both sides. We get x squared equals negative 25. Now, how do I undo, right, the square, x squared? I take the square root, right, both sides. And remember, when you take the square root, you always get plus or minus. It doesn't matter that this is negative, right? Whether it's negative or positive doesn't matter here, right? Here it was positive. Here it's negative. Doesn't matter. You still need the plus or minus, because when you take the square root, you get the square root of negative 25, right? So the negative stays with the 25. It's under the square root, right? So what do we get? We get x equals plus or minus. So now, right, in the last video, we talked about this, right? When you have the square root of a negative number, it's going to be the square root of a positive number times the square root of negative 1. So this is why we had to talk about, right, imaginary numbers, because they do end up as solutions to these equations. Right? So this is an imaginary number, right? X is going to be plus or minus. The square root of 25, right, as it was down here, is still just equal to 5. Right? But the square root of negative 1, we gave that the name I, right? I for imaginary. Right? And then these are the solutions, right? Let's write them separately, right? You have x equals positive 5i as one solution, and then you have x equals negative 5i for the other solution, right? So yeah, you still get two solutions. One's positive and one is negative, right? But they're both imaginary. Right? And that might make some sense now, because remember, we tried solving it by factoring, and we said it doesn't work. Right? This is prime. This can't be factored. And now we know why. Because when we factor, we're not looking for, 5i. We're not looking for imaginary numbers. We're looking for, nice numbers, like negative 5 or positive 8, right? There's no i's here. right? So for the last problem, we didn't get 8i or negative 5i. And again, you're not going to look for that when you factor. So this is why sort of trying to factor this was doomed from the start. This was not going to work by factoring, right? So yeah, but the square root method worked perfectly, right? We got our two solutions, and you can check by plugging this back into these equations that they work. Okay, so that's how the square root method works. We'll do some more examples, of course. This is just to give you the idea. Okay, so let's scroll down. Again, here's the square root method. So let's do another example. I think we're up to example 4 here, right? Yep, so let's solve. How about the equation m plus 4 squared minus 12 equals 0. Okay, so this may look like it's in standard form, but it's not, right? Because, right, we don't know what a or b is here. Or actually, we don't know a, b, or c. You might think the c is negative 12, but it's not, right? So one thing you could do is expand this out, but that's not going to help here. Trust me, it's not going to make this any easier. Okay, so in standard form, this would become m squared plus 8m plus 4 equals 0. That's supposed to be a 0. Sorry about that. And now this is in standard form. But that doesn't make it any easier to solve. In fact, you can try to factor it. Right? So what two numbers multiply to 4 and add to 8? Well, you can try 1 and 4. But 1 plus 4 is 5. So that doesn't work. The only other option I can see is 2 times 2. Right? But 2 plus 2 is 4, not 8. So, yep. So it turns out that this, right, this m squared plus 8m plus 4 is prime. It's not factorable. So this was not going to work, right? Scroll down just a little bit, right? So what can we do then, right? So we have m plus 4, the whole thing squared, right, minus 12 equals 0. So we're still going to use the square root method. We're going to use, this up here. And you can see what my u is here, right? My u is just what's in the parentheses. It's the m plus 4, right? So I have u squared minus 12 equals 0. Now, so what's n? So it's not negative 12 because that's on the wrong side, right? We have to add the 12 to both sides. So when we add 12 to both sides, right, the equation becomes m plus 4, the quantity squared, plus 0, right, equals 0 plus 12, which is 12. Okay. So why is it called the square root method? Because we want to get rid of the square. We want to undo the square. We take the square root of both sides, right? And then we get on the left m plus 4, and on the right we get the square root of 12. Except we don't. I'm pulling a fast one here. What am I missing? Right? This is a very common mistake. Remember, anytime you take the square root of both sides, plus or minus, right? Plus or minus. So, yep, I forgot the plus or minus symbol in front of the square root, right? So don't forget the plus or minus, because you need both the positive and the negative solutions here, right? Okay, so we're almost done, because on the right side, we have plus or minus the square root of 12, and on the left side, we have m plus 4. So how do I get rid of the 4? Well, the opposite of adding 4 is subtracting 4. So I'm just going to subtract 4 on both sides, right? Because then, yep, 4 minus 4 is 0, right? And so I just get m on the left, and then negative 4 plus or minus the square root of 12 on the right. And there you go. These are the solutions. But, okay, we're not quite done. We're not quite done. So, yeah, since I'm running out of space, let me go up here, right? So here's the issue, right? It's not the -4. It's not the plus or minus, although we could split that up as two solutions, right? The problem is the square root of 12. And if you remember, in the last chapter, in chapter 10, we learned how to simplify the square root of 12, right? We're looking for factors that are perfect squares. So, right, so we could do 6 times 2, but neither 6 nor 2 are perfect squares. What about 4 times 3 is 12, right? 4 times 3 is 12, and 4 is a perfect square. So because it's a product, we can split that up as the square root of 4 times the square root of 3, and the square root of 4 is just 2, right? So, yep, another way to write the square root of 12 is 2 square root of 3. And so you should do that here as well, right? So, yep, so let me erase the 12 here and just put 2 square root of 3. So the 2 goes in front, and then the square root of 3. And yeah, so that looked a little awkward. I just moved the plus or minus symbol around. So there you go, right? This would be an acceptable answer here, right? Or you can write them separately, right? So you can write m is -4 plus 2 square root of 3. And then the other solution is -4 minus 2 square root of 3. Okay, so same thing. Again, this symbol, plus or minus, means both the plus and the minus together. So it's good to write them separately because they are two separate numbers. You're just writing them both at once here. Right? In this form, you're writing them both at once. Okay, so we getting the hang of the square root method. Maybe we'll try one more and then move on. Oh, okay. So I think I have just enough space for one more. So I think we're up to example 5. Yep. All right. Suppose we want to solve. Yep. Let's just do p squared plus 80 equals 0. Okay, so yes, we did one like this earlier. This one's a little more routine. And the idea is, right, we're not going to be able to factor this. This is going to be prime, right? Look, 80 is not a perfect square, but even if it was, right, the sum of squares is prime. It would have to be p squared minus 80, or, you know, something like p squared minus 81. 81 would be a perfect square, right? So that would work, but not here, right? So we're going to have to use the square root method. And for the square root method, right, we have to get the 80 to the other side. So here we're going to subtract 80 from both sides and write p squared equals -80, right? And then how do you undo the exponent of 2? How do you undo the square? You take the square root, right? And that changes it to just p. And so you got to do the same thing to the right side. You take the square root of -80. Don't forget plus or minus, right? Always plus or minus whenever you take the square root, right? Right. So again, you get two answers here. One positive, one negative, or square root of -80, I should say, right? So, yep, just like in the last problem, we have to simplify this. And the way to do that is I'll keep the plus or minus so we don't forget that. Yeah, we have the square root of positive 80 and the square root of -1. The square root of -1, of course, we use the letter I for that. And then what about 80? So it's not a perfect square like 81, but some of the factors are perfect squares, right? So, yep, you don't want to do 8 times 10. I mean, you could, but you'd have to keep going. We could do 4 times 20, but 20 is also 4 times 5. So 4 times 4 is 16. and 16 times 5 is 80. So if you didn't follow that, right, just do the factor tree, right? Do 8 times 10, and then 8 is 4 times 2, and 10 is 2 times 5, and 4 is 2 times 2. So we have 1, 2, 3, 4 2's, right? We have 2 to the 4th times 5. That's times there, right? And 2 to the 4th is 16. So it's not only a perfect square, the 16, it's also a power of 4, but we're taking the square root, right, not the 4th root, so the square root of 16 is just 4, right? So this is going to be, oops, forgot the square root of negative 1, so plus or minus the square root of 16 times the square root of 5 times the square root of negative 1. And so when you simplify all that, you get plus or minus 4 times the square root of 5, oops, that's a 5, and then times I. Okay, well, we can also put the I in front, not in front of the 4, but in front of the square root, right? So I would prefer to put plus or minus 4i and then the square root of 5. But look, either way is fine. If you leave the I at the end here, I'm okay with that too. But not with this, right? You're not taking the square root of I. So, yep, you cannot have the I under the square root. Okay, so this would be okay, but not when you have the square root over the I, right? Okay, so there are the answers again. 4i square root of 5. And remember, there's 2 of them, so you can either leave it like this, or you can write them separately, right? You can have 4 times I times the square root of 5, or you can have negative 4, right, times I times the square root of 5. And that's supposed to be an I. There we go, right? And, well, this is supposed to be a P here. So, okay, so that's it for the square root method, right? It's just, right, here it is again. All you're doing is isolating the perfect square on the left side, and then the number on the right side, and then just taking the square root of both sides. Okay, and when you do that, you get rid of the square, so you're solving for usually x here. I mean, here we were solving for m plus 4, so we had a little bit more work to do in subtracting the 4, but generally speaking, you're just solving for x in the square root method. Okay, so that's the square root method. Oh, maybe we'll do one more. We'll do one more, but I gotta start over because I'm out of space. Okay, last one, and yeah, this is probably one of the more difficult ones you would encounter, but it's still the square root method, right? So yeah, in fact, the directions will say solve by the square root method, or solve by taking square roots, right? So all of this here is my u, right? So my u is just 3y minus 2. So we're not going to multiply this out here, right? We're just going to leave it as 3y minus 2 squared. Okay. Right. Now, in order to get rid of the square here, we would take the square root of both sides, but notice the number here is on the wrong side, right? We need to subtract, 72, from both sides. So on the left, we still get 3y minus 2 quantity squared. And then on the right side, right, 72 minus 72 is, right, plus 0. So you don't have to write 0 here. But on the right side, we have 0 minus 72, which is negative 72, right? Okay. So we have our u squared equals n, right? U being the 3y minus 2, and the n being the negative 72. Okay. So the square root method just says take the square root of both sides. Again, don't forget the plus or minus. So if we take the square root of the left side, we just get 3y minus 2, right? This square here, or sorry, this square root undoes the square. just cancel out. You know, if you just take the square root of x squared, you just get x. Unless x is negative, in which case you get absolute value, but that's going to be taken care of in the plus or minus, right? Right? You don't have to worry about the absolute value if you don't forget the plus or minus. Make sense? Yeah, I forgot to do plus or minus square root of negative 72 here. Right? Okay, and so obviously we're still solving for y, right? So we're going to add the 2 and then divide by 3. But before we do that, we might want to simplify this square root of negative 72. So let me do that over here. That's my scrap work here. Right, well, it's a square root of a negative, so this will be another imaginary number. It'll be the square root of positive 72 times the square root of negative 1. And then 72 is, I think, 36 times 2. 36 times 2 is 72. And the square root of 36 is just 6. And then the square root of 2 is the square root of 2. That's as simple as that gets. But the square root of negative 1 is also I. So if it's all the same to you, I'm going to put the I in front of the square root. So 6I times the square root of 2. Okay, so having done that, now I can rewrite the right side as plus or minus 6I times the square root of 2. Okay. All right. So now what? Well, remember, we're solving for y. Our goal is to get, y equals what, right? So to do that, we want to get rid of the negative 2 here. Right? So the opposite of subtracting 2 is adding 2. So I'm going to add 2 to both sides, right? Left and right. And on the left, this adds to 0 now, so we still get 3y plus 0 equals, and then notice where I put the 2. I put the 2 to the left of the square root, right? That's the conventional place to put it here. So you could, of course, write this as plus or minus 6I squared of 2 plus 2. So if, because we did that on the left, we put the 2 on the right side, and we could have put the 2 on the right side of the square root here. There's a slight issue with this in the sense that this might be a little bit ambiguous. Does the plus or minus include the 2 or not? Obviously not, because we don't have parentheses or brackets around it. So yeah, I guess I'm not going to be that picky about it, but strictly speaking, it's much more conventional to put the positive 2 without the square root in front of it. Right? So then the only thing left to do is divide both sides by 3, because this is 3 times y. The opposite of multiplying by 3 is dividing by 3. Right? And now we're going to get, on the left, the 3's cancel. 3 divided by 3 is 1. So we get y. And this is what we get on the right. 2 plus or minus 6I squared of 2 all over 3. Okay? And in fact, we could just leave it like this, right? There's no problem leaving it just like this. And just going by what some of you are probably thinking, and I hope you're not, wait a minute, isn't 6 divided by 3 2, right? So why can't I just simplify this and write it as 2 plus or minus 2I squared of 2? Why indeed, right? Because that would be wrong, right? This is not, this would not be a 2 here, right? Because remember, you're adding and subtracting. You're not multiplying. 6 is only a factor of the second term here, not of the first, right? So this would be wrong. What you could do, however, is the following. You could split this up and write it as 2 over 3 plus or minus 6I squared of 2 over 3. Now, right? Now in this case, the 6 is a factor of just the numerator, right? The 6 does not multiply the 2 here, right? That's why you can't cancel these, right? But now you can, right? So now I could write this as 2/3, right? Plus or minus 2i squared of 2. You see that? So you might think, well, didn't we have that already? No, what we had was this, right? We had 2 plus or minus 2i squared of 2. So in fact, you could say that this 2 was correct, but then this 2 would have been wrong because it's 2/3, not 2, right? So once again, right, this is wrong because you cannot cancel the 6 and the 3 here. 6 divided by 3 is 2, but because you're adding and subtracting, right, terms don't cancel, only factors cancel. So yeah, another common mistake, right, if people do this, yeah, the 6 and the 3 here can cancel, oops, right, but not here. So I know that seems like splitting hairs, but I assure you it's not. It's very important that if you want to cancel these, you got to split it up first, then cancel here, and then you would be okay, right? Yeah. So yes, we could write it this way here. This way is correct. It's equivalent to this. But generally speaking, I tend to leave it like this, unless you can factor out of both terms, right? So if this 2 here were, say, a 12 or a 6 or a 3, then you can factor out that 3 or 6 or 12 or whatever, and then, and then cancel. But in this case, you can only cancel, right? 2 is not divisible by 3. That's why we leave it as 2/3. But the 6 is divisible by 3, but you can only do that after splitting up your terms here. So yeah, tricky problem, but yep. And again, I would prefer to leave it this way. If you want to write it this way, that's okay too. And again, in Connect Math, I would hope it accepts both, but if not, I would give you full credit for both versions here, obviously. Obviously, I would not give you credit for this because, as I mentioned before, it is wrong. It is incorrect, right? It should either be 2/3 plus 2i squared of 2, or, right, it should be 2/3 plus 6i squared of 2 over 3. So I hope that helps. And so that's it for the square root method now. Next, we're going to go on to completing the square. But you have to get used to the square root method before you can complete the square. So make sure you know the square root method inside and out here.